Really excited to hear your presentation. And it sounds like we're now recording. So take it away.
All right. Well, thank you so much for having me here. I'm looking at who's here. I always look at the participants. I'm that person who likes crowd watching, and this is the Zoom version. And I'm really excited because I don't know most any of you. And I spend a lot of time talking to people about plastics and health and microplastics. And oftentimes it's the same people or many of the same people, and it's nice to have familiar faces, but it's really good to continue to grow the audience, to have a big umbrella. And I'm also really excited by how many of you are nursing students and a couple of physicians. Is this group generally a medical oriented group? I know you're climate action, but are you medical climate action? Oh, okay. All right. That makes sense then. I'm like, wow, somebody got the word out. Well, still, I know I'm in the right room just looking at you all. So thank you for the invitation. I'm going to share my screen. Dum-dum, here we go. Slideshow. And sorry, one other little thing I'm doing here. Hide self view. If you can see yourself while you're speaking, it's like being a deer in headlights. Like, I look like that. Okay, so the race to research plastics and human health. Um, Lots to talk about here. As little as 4 or 5 years ago, the term microplastic was new. I remember when the New York Times nominated it as like the new word of the year, like dumpster fire. It was like the buzzword that had just suddenly cropped up. And now, I challenge you to find an audience that like listens to the radio, watches television, or is in any way on the internet that hasn't heard the term. So I've been involved in this for a while. I will say my background is history. I cut my teeth as a historian, reading a lot of medical and public health history. And one thing that I learned there that I've taken forward as I've worked into environmental health is that history is not inevitable. And this is the good news part of it. Like, it's not inevitable. People make history. There's not really a passive voice in history unless you're trying to hide something or someone, because people make decisions based on the situations that they're in, the social context. And as you look at who made those decisions and why and what the context was, it gets easier to unlayer how we got to where we are today and how we're going to get out of it. Problems that are not inevitable are solvable. And that's actually why I was reading history in the first place, because I wanted to know, like, how did we get into this mess and how are we going to get out? So, okay, how are we going to get out? Well, I spent plenty of years trying to figure out how I could help on the climate fight. I started out as a medical historian and as a public health doctorate. What am I going to do with that? And I gradually realized, oh, I'm actually not a bad organizer. And I work really well with healthcare personnel, especially physicians and researchers. So in February of this year, I launched a new organization called PSNAP, which is the Physician and Scientist Network Addressing Plastics and Health, which draws in who it says it's drawing in, although I should probably put an extra N in there for nurses because it's a healthcare umbrella. But I wanted to work with this population because we have outsized credibility and outsized power in our social context today. And I know it's easy not to feel that way, especially after COVID and the way that science seems to be so under attack. It's like we need a grassroots movement to make people believe in science. And yet, even in our very bipartisan society, people do sit up and pay more attention if it's Dr. Such and one or Nurse Such and one delivering a message that has to do with health and has to do with one's body. So we've been pulling in people and it's growing a lot faster than I thought it would. We're already, just this far in, what is it, 9 months in, 110 people. And my favorite part is the 27 different kinds of specialties, really multidisciplinary. Nurses, public health people, pediatricians, OBGYN, internal medicine. We've got a lot of people coming from a lot of different thought patterns, parts of the clinic, parts of the world. We've got some polymer chemists who are all touching different parts of the elephant, but who are all in it together, having conversations with each other, networking and trying to kind of pool our collective knowledge and skill to get onto this problem. So it's been a lot of fun. Um, Well, here's the problem that we're tackling. Um, at the outset, on its face, the most obvious piece of what we call the plastics crisis is volume. We've managed to produce nearly 10 billion tons of plastic since 1950. And where are we going to put it all? There really aren't any plastic pollution deniers because everywhere you go, you're going to see plastic trash washing around, blowing around, hanging in the trees. And it's much worse when you get out of the developed world. For us, about 3% of what we're dealing with is just litter. But when you get out of the developed world and you get into places that don't have significant trash hauling or waste disposal, you're running into open burning, open fires, and a lot more plastic all over the place. So this is what it looks like at the outset. Why is there so much of it? Lots of reasons for that. But at the very base, we know plastic production doubles about every 14 years, and it's on track to triple by 2060. So one of the main things to take away from the rate that plastic grows is it's never consumer driven. It's always been manufacturer driven. And there's always been a lot of work between the plastics and the petrochemical industry and Madison Avenue to create new markets for a product that's basically very inexpensive to produce. At this point, fracked ethane gas, which is the basis for most polyethylene or ethylene plastic, is free for the cost of shipping. It's a byproduct. So being able to send it out into the market and sell it is a huge win for the producers. And that's why it's moved up so quickly. But as it's moving up directly in conjunction with synthetic chemical production. Because plastic is a synthetic chemical product. It is a petrochemical product. Most of the chemicals that are produced today, 70% of them go into plastic. We manufacture 10 times more plastic than we do pesticides annually. And we're dealing with the same kinds of hydrocarbons, the same kind of molecules that we worry about in pesticides. We haven't really gotten there in plastics, but they can function in many of the same ways. The majority for plastics remain untested. The country of origin is unlabeled. There's chronic universal human exposure, which is important to think about because we live in a plastic world. Some of it is very necessary plastic. Some of it is maybe necessary, but we could probably swap it out. And some of it is totally ridiculous, the added layers of packaging and so on. But it's all around us. It's mostly the interior of our homes and workplaces where we spend 90% of our time. And we really can't get away from it. But it's received almost no attention from EPA or from FDA for that matter. So we're dealing with an unmonitored, unregulated petrochemical substance that's around us all the time. That's worrying. I think about it this way. Because plastic is a petrochemical product, very much like pesticides being a petrochemical product, it's come to us recently. And Rachel Carson was really the first person who had a lot to say publicly about this new petrochemical era that we were in after World War II. She was concerned, she said, given time, not time in years, but in millennia, life adjusts and a balance has been reached. For time is an essential ingredient, but in the modern world, there is no time. Doubling every 14 years, increasing production at the rate that we're doing without any pre-market testing doesn't leave our bodies or our environment much time to adjust to what's being flooded into it. So what is being flooded into it? I don't know how many of you are familiar with this schematic. It's the planetary boundaries idea. It was coined, oh gosh, as the historian in me is like, how can you not remember? 2013, maybe it was 2018. But anyway, it was in Stockholm. And its authors separated different parts of the Earth's resources into sectors to see, well, how much are we overburdening, say, ozone depletion or ocean acidification? What are the safe boundaries for human existence and planetary health? And it's this one up here, the novel entities that we're talking about with plastic. Now, every time this thing gets updated, it gets a little bit more scary. And the novel entities are the ones that have really shot out beyond almost anything else. And what we're talking about here are novel synthetic products like chemicals. How many do we have? We really don't know. But about 350,000 have been registered for global production. So those are the ones that have been identified, and the synthesizers have actually come forward to the government and said, this is what we've got. Of the ones that are registered, 50,000 are confidential, meaning that they're trade secrets. 70,000 of them are ambiguously described, meaning that the creators, the synthesizers, they didn't describe them in such a way that anyone would ever really understand what they are or how to replicate them. So it's the same as being a trade secret. Only about 3,500 have ever been studied, and of those, we really only understand the large-scale impacts of 65. So we've flooded our planet with chemicals about which we don't know much. That's the basis of the material. When you get to plastics themselves, though, here we go with microplastics, which we've now all heard of. Plastic does not break down in the environment. It breaks up instead. First into macroplastics, just pieces, bits. And anything that you leave outside in the yard or on the driveway or anything like that, over time, the UV rays it'll become brittle. And the more brittle it becomes, the more likely when you touch it or run it over with the car or step on it, it's just going to shatter. And those ones that you can see, the bigger ones, are macroplastics. When they get down beneath the size of a pencil eraser, they're microplastics. And microplastics can go down to a grain of sand. If you can still see it, it's a microplastic. Nanoplastics are what the researchers are thinking and talking about the most right now. And I think that tide turned about 12 months ago. Nanoplastics are so small. Well, here, I'll give you a schematic. So we've got microplastics here, width of a pencil tip, a grain of salt. They can be inhalable, but our lungs are actually adapted to be able to cough out stuff like that. So, okay, they're not really crossing into our tissue, but nanoplastics are something very different. Still plastic, still getting smaller and smaller, but the size of a particle of smoke, or the SARS-CoV virus, or the width of a strand of DNA. Once it gets down that small, it's what's called respirable, meaning it's going to cross the alveoli of the lungs and into the circulatory system. And the same thing happens in the intestine. When it gets to be so small, it's nanoplastic, it crosses through the intestinal wall and into the blood circulatory system. So that's why we're more worried about nanoplastics, because they can penetrate farther, and as a result, they can carry those toxicants, those chemicals, in further and do more damage than we ever realized was possible. Now, on the micro level, we had come to know, as long ago as 4 or 5 years, that everywhere anybody ever looked for microplastics, we were finding them on a snowflake or inside the vasculature of a plant. And this is because microplastics, even when they're still reasonably large, they can be taken up by the hydrologic cycle. They just evaporate with the water, and then they come down everywhere. And they're also taken up as dust and particles. So the energy that is the Earth's dynamic systems has been carrying microplastics to the furthest corners of the planet for decades without our realizing it. Here's an example of how far it can get. This is microplastics that were on the body of an insect found in Adirondack State Park in January of 2023. Now, Adirondack State Park is massive. It's upstate New York, and it's the most pristine area in New York State. Now, that might not sound like a lot. Like, it's New York, how pristine are you going to get? But still, there's no manufacturing, there's no recycling, there's no major dumping anywhere near the Adirondacks. For this insect to become this coated, those microplastics have to have come on wind and through rain. And they're coming at this degree, to this level. So what does that mean? There are microplastics in the air, there are microplastics in the water. Because of that, they're in the plants, we know they're in our food, and of course we're wearing a lot of synthetic fibers, anything that's polyester or nylon, or you just look at any tag of what you're wearing. 70% of textiles currently under manufacture are made from petrochemicals. So it's in contact with our skin. So it's getting into us. And that's where people are starting to really get worried, and that's where the research has been going. You've probably heard the statistic that we each eat as much as a credit card a week of plastic. That was a bit of an overcount. It came out of the University of Newcastle a few years ago, and it created a lot of controversy. And frankly, what the article said was, some people under some circumstances might eat as much as 5 grams of plastic a week. And the press took it and said, we're all eating 5 grams of plastic a week. But still, even if you're not eating a whole credit card, it's alarming. And it really penetrated the public mindset, but there's not a lot we can do about it. There's not a lot you can do to really protect all the air and all the food and all the water you drink and so on and so on. You know, even if you were in a bubble, it would still probably be made out of plastic. So the internet replied in the way that the internet tends to, with gallows humor and memes, like microplastic spices, or this is from the New Yorker, microplastics that can be spread on your food. This is one of my favorites, the 2030 food pyramid with antidepressants at the top and microplastics at the bottom. I think I will eat microplastics on purpose. And this was somebody's Reddit comment. I eat a credit card every Sunday just to get it all out of the way and have a nice plastic-free week. So we're laughing at this, which is nice, right? Like that's a good reaction to what we don't know much about and don't feel empowered to change. But let's think about it as clinicians, as scientists, as practitioners for a minute. I've already dwelled on all the chemicals that go into plastics, and 99% of plastics are manufactured out of fossil carbon. So fracked gas, oil, coal. In order to turn, say, a lump of coal or a measure of petroleum into plastic, you need a lot of additives. It's going to be pink, it's going to be squishy, it's going to be see-through, it's going to be, it's not going to burst into flame because after all, it's made out of petrochemicals. So you're adding a lot of additives. The most recent head count on these additives came out in March of 2024. It was 16,325, which the prior year, the number had been 13,500. So almost as fast as we can research this, the numbers are going up almost, they're doubling and tripling. But what we knew about the ones that we published on, I wasn't part of it, I didn't publish in 2024. This group, the PlastChem report published on, they found that of the ones that have ever been studied, which is over here on the right, well, 26% of all of the plastics are known to be hazardous. And what does that mean? It means that they're carcinogenic, they're hormone disruptors, or they do derail neurodevelopment. So they're neurotoxicants. That is undisputed. We know that about a quarter, more than a quarter of all the chemicals that go into plastics. 7% are what's called less hazardous. That's just hedging. Less than 1% are not hazardous. But then this is what really worries the researchers. These are the unknown unknowns. Given the proportion of what we do know, this is not looking good. If you want to extrapolate from what we know and think, okay, well, this pattern is likely to persist, we're probably dealing with a lot more worrisome chemicals than we realized. This is the only chemistry slide I will show you, I promise, but it's worth thinking about. We got a polymer backbone that is the backbone of all plastics, carbon-carbon bonds. And if you remember high school chemistry, which I do, but vaguely, carbon-carbon bonds, they're covalent, they're double bonded, so they're very difficult to break. And that's why plastic is so durable. And then these additives, this is just a few of the 16,325, here's 4. Phthalates, bisphenols, PFAS, and brominated flame retardants. Now all of these are pretty much on the do not eat list. And they're all going into plastics, different kinds of plastics, but when they go in, they just sit inside the matrix of the molecule. They're not bonded, which means that they can migrate out at any point that the plastic exists. Well, the plastic will always exist, and the chemicals, the additives will always be migrating out. So we have ourselves kind of a hot mess, frankly, that we create and then we put out into the world. And if you take any one thing from this lecture tonight, it's this: do not microwave any food in a plastic container. Even if it says microwave safe, what they're talking about is the container, not the food. It means the container isn't going to visibly denature, but the added heat energy is going to cause those molecules in your food to move around more, and that means, and also the molecules in the plastic, it's going to help those chemicals migrate or leach into the food. So that's one pointer, and you can tell your patients too. So don't cook it in plastic, don't microwave it in plastic. And try not to cook with plastic either, like spatulas, Teflon, that sort of thing. Well, where are the microplastics? By 2018, we'd figured out that they were in human feces, which meant they were definitely in our bodies. But were they sticking around or were we passing them? Started to look like some of them were sticking around. In as recently as 2020, researchers, scientists still hoped that there were three barriers in the human body that they would not be able to cross. One would be the placenta, another would be the barrier surrounding the testes, and the third would be the blood-brain barrier. But in 2021, an Italian team demonstrated pretty clearly that microplastics were crossing the placenta. They were present both on the fetal side and the maternal side. And at this point, we have a lot of data that correlates microplastics in the placenta to preterm birth and other unfortunate, less fortunate outcomes. This set off a real race to find other places that the microplastics were, and the researchers did not disappoint. So here's a quick synopsis of what they found from then to now. And this is just a thumbnail. There's a lot more in a lot more places, but meconium, that's the first stool of a newborn baby. So before a child has even eaten anything, it's already passing microplastics. Sputum, blood, breast milk, liver, urine, veins. Now, blood and veins, that got attention because we were thinking about the blood-brain barrier. And, if it's in the blood, where's it moving around to? Boom, testes. Okay, so that's the second barrier that it's crossed. Heart tissue, kidney, carotid plaque, brain, blood-brain barrier, May of 2024. And on it goes, bone, follicular fluid, and so on. So yes, the human body contains microplastics. What does that mean? What's going on inside? Well, most of the studies that we have at this point are pretty speculative. They're correlative. They're not, you can't say causal even when you really, really have it locked down. The correlations, though, are extremely strong, particularly in this article. This came out in the New England Journal of Medicine. So it's like beyond the threshold of like any kind of deniability, right? Or impeachability. And this was a study many of you probably heard about, where doctors looked at the carotid plaque that they'd removed from patients, and they analyzed it for microplastics. And they had a cohort of more than 300 patients, 58% of whom had microplastics in their carotid arteries. They then followed them forward for 36 months. And they found that patients who did not, or rather patients who did have MNP as micro nanoplastic, patients whose arteries had MNPs had a 450% increase in heart attack, stroke, and premature death over the patients who did not have the microplastics in their plaque. So it's one study. It has not yet been replicated. And it's correlation, so, okay, but it sends an enormous signal, a signal that you don't often see in environmental health research outside of like a toxic zone, a major, major spill. And here's the other study that basically broke the internet, the Campen lab. This is the lab that found microplastics in the brain. And the way they did this was pretty interesting. The microplastics in the brain were very hard to visualize. Basically, nanoplastics are in the brain. And the way that they managed to identify them was to use a solvent to dissolve the brain tissue of cadaver samples. So they had samples from a cohort of people who had passed in 2016 and a cohort who passed in 2024. And they dissolved the tissue, and then they looked at what was left, and they analyzed what those materials were. And they found, yes, a lot of plastic. Now, while they were doing that, they also looked at liver tissue and kidney tissue from the same cadavers so that they could compare where was the microplastic and the nanoplastic really collecting, which organs had the most of it. And what they found was concerning. They found, first of all, yes, there's microplastic in the brain. There's a lot of microplastic in the brain. They calculated that it could be as much as a plastic spoon of microplastic. And we're not talking like a spoonful, it's the spoon itself in any given brain. Now, Matt Campen, who was the PI, said that's probably an overstatement, and he hopes that it's an overstatement. but it's what they calculated based on the density of the tissue that they found. Of that, polyethylene was the most common polymer. Well, that's also the most common plastic. So, as they used to say in the phone book commercials, if it's out there, it's in here. They also found that micro and nanoplastics were selectively accumulated into the human brain, meaning there were more in the brain tissue than there were in the liver and kidney tissue. That was surprising for a couple of reasons. We associate liver and kidney as not cleansing, but well, I guess yes, cleansing organs. You know, they're detoxing the body. So if we're going to be getting rid of microplastics, they should be collecting there, right? But instead, there's more of them in the brain. And the theory behind that is that a lot of the chemicals in plastics are lipophilic. They're attracted to lipids. So the brain, being the fattiest organ in the body, is a pretty good place for them to wind up. Also, the brain uses a lot of energy, so it takes in lipids. If you have micro nanoplastics that are in lipid droplets, they're going to be selectively brought into the brain to use for energy. So that might be what's going on there. And that would also explain the carotid plaque finding. They found that brains with people with a history of Alzheimer's or dementia had 5 to 10 times more plastic than those who didn't. And this was the real kicker. It's like the other ones weren't scary enough. This is the scary one, but kind of is. The total plastic mass concentration in brains increased 50% between one cohort and the next, between 2016 and 2018. And that was jarring enough. Campen went back and obtained samples from cadavers from other states and many other years and wound up plotting a graph that was just, you know, it was exactly, the curve did not move. The earlier the people had died, the fewer microplastics they had in their brains. And, you know, his thinking is we've probably reached a point now where the nanoplastics that have been lying around, well, the plastics that have been lying around have reached a point that many of them have managed to flake off nanoplastic particles that are capable of getting in here. So we're reaching sort of a background point. I hope that I hope I just said that in a way that made sense. So that's really upsetting. So here's some kittens. Let's just take a breath here. All right, so our background load of nanoplastics is growing. By the way, all plastic goes to micro and nanoplastic sooner or later. Think of it like skin constantly loughing off cells. But oh, these kittens are cute. Okay, and we'll go on. So what does all this mean? Well, that's what everybody wants to know, and that's what the researchers are scrambling to determine. And they've sort of got it down to like two different tranches of effects. Particle effects, which are, okay, you have a foreign body, you have, you know, an invasive thing that's not supposed to be there. And is it doing mechanical damage? Is it banging into cell membranes? Like, what is it doing just as a particle that's not supposed to be there? And then the chemical effects from everything that we just talked about that's part of the plastics itself. This was a comment made by a colleague of mine who said, you know, it's the crux of the issue here, no matter how you slice it, is that the chemicals are locked up in those micro and nanoplastics. They last longer in the environment and they penetrate more places than they otherwise would. So, you know, whether it's the heat or the humidity, you're still going to have a problem, and a much greater problem than we realized that we could have from a material like plastic. Mostly the researchers are looking at the chemical effects because we have more data. It's easier to assess. The particle effects, unless your spectroscopy is, or spectronomy, your microscope technology is really amazing, better than frankly exists right now, there's a limit to what you can see. And that something becomes more the more we can magnify. But what we can think about is this Trojan horse model, where those micro and nanoplastics, as they move into tissue, are going to be releasing the chemicals. They're going to be migrating and leaching out of the plastics for as long as those particles are in the tissue. So that's the way that most researchers think about this. And then they think about, well, okay, so what are those chemicals? What are they capable of doing in humans? We're not going to have a randomized system or, you know, anything like that where we're intentionally dosing humans with plastic and microplastic, but we're all already dosed. So what are we seeing and how does that correlate with the potential of the chemicals that we know are now getting into the human body. And this is the one that has researchers most on edge. This is where most of the attention is going, which is the capacity of so many of these additives to disrupt the endocrine system. They're what's called endocrine disrupting chemicals, EDCs. And what they do is they can be agonists, so they can bind to hormone receptors. So when the real thing comes along, whoop, no parking here. They can hang out in the bloodstream and other tissue and bind to hormones that are out there. So those hormones are then going to not bind. And they can also impact gene expression. And this is the really big one, gene expression itself, causing the body to produce unexpected or dysregulated quantities of hormones. And when that happens, it impacts every system in the body. When I'm talking to college students, it's mostly like, okay, what's estrogen and testosterone doing? Those are the fun sex hormones. But your pituitary, your thyroid, everything metabolic, insulin, it's all hormones. Homeostasis is based on hormones. This is, as we get the researchers most worried, this is where a lot of attention is going. It's the capacity of those hormones to turn on and off the gene signaling. So you have a gene that's encoded to create this or that, and then a hormone comes along and triggers it, and it produces the protein. Well, if you have endocrine disruptors that are disrupting the hormone system, then gene expression actually gets hacked. And if that happens in fetal tissue, you can wind up with permanent damage, developmental damage, which means that the greatest point of vulnerability for endocrine disruption is for children, for fetal development, newborns, babies, and toddlers, people who are still laying down the hardware that's going to conduct all the signaling that their bodies need throughout life. This is Pete Myers's line, what happens in the womb doesn't stay in the womb. Now, Pete Myers is the guy who actually coined the term endocrine disruption. So he's got a lot of good ways of phrasing things. But in this one, it's the timing that makes the poison. And that's also important because I'm sure you've heard the expression, oh, the dose makes the poison. Not so. With endocrine disruptors, the tiniest quantities, parts per billion and parts per trillion, have the capacity to change the expression of these genes. And here's an example from the lab. So these mice were dosed prenatally with diethylstilbestrol, or DES, and that has a long and awful history in healthcare. DES babies, you may remember, were the children that were born to women who took it. It was supposed to prevent miscarriage, I believe. And it turned out, although the kids were born looking perfectly fine, most of them, girls started developing cervical cancer at much greater rates. And then also it turned out as they reached adolescence and womanhood that many of them had deformed uteruses and so on. So this chemical prenatally impacted the reproductive health of many young women. And it's also been demonstrated that the boys were not spared either. We just weren't looking. So the more we study the DES sons, the more we see. But it's still a useful thing for studying hormone disruption, endocrine disruption, because we know how bad it can get. So these mice were dosed prenatally with 1 part per billion. And within the study, different mice were dosed at different times in gestation. So say second trimester equivalent for a mouse or third trimester equivalent for a mouse, those offspring didn't seem to have any particular problems. But the 9 to 16 days gestation mice, although born looking perfectly fine and normal, over time became morbidly obese against the control mice, which, given the same caloric intake and the same amount of exercise, did not become obese. This endocrine disruptor had disrupted the metabolism of the mouse. And these effects are transgenerational. So the next generation of mice also experienced greater obesity, and their offspring as well. A lot of studies demonstrate that this can just keep on going on. Part of that has to do with the fact that we're all constantly re-exposed. So there are a lot of question marks about, like, does this ever end? But basically, we know that we've created a generational toxicant here, and vast levels of epigenetic change. Let's go forward. Come on, slide. There we go. Here's another example of what it can do. This is a metaphor that Leo Tresande, he's a researcher and physician at NYU, uses to describe this. So the brain, the developing brain, is an amazing thing. It's laying down neurons, it's laying down its signaling pathway incredibly quickly. The cells are dividing and migrating to where they need to go, and they're getting into contact with each other. It's an amazing dance. It happens super fast. And what it's doing is effectively laying down a rail system on which the signals that our thoughts and impulses and all of our mental work are going to travel for the lifetime of that being. This is the New York City subway system. Now you can imagine what happens if that gets derailed by an endocrine disruptor. You have cells that aren't going to the same places, they're not connecting with each other, their connections are wrong and off and clogged. It's the equivalent of train lines not intersecting. So signals are not going to get to where they need to go as quickly as they need to, or nearly as efficiently. And then that's how we start getting neurodevelopmental disorders. And this is correlated with ADHD, with autism, with autism spectrum disorder, a number of neurodevelopmental disorders that are all on the uptick at this point. It also impacts a lot of reproductive health. Now, DES was sort of the tip of the iceberg. We've known for a long time that sperm counts have been declining since 1972. Shauna Swan, who's an investigator who's been looking at this for many years, calls it the 1% hypothesis or theory, where effectively we've been seeing sperm counts go down 1% per year for 50 years. So sperm counts now are 50% lower than they were 50 years ago. But that rate of decline has accelerated since the year 2000. She looks a lot at phthalates and at bisphenols, and in the lab sees some direct correlation between prenatal and perinatal exposure to phthalates and bisphenol and reduced sperm counts, anogenital distance, other items that signal fertility problems in males and also in females. So here's some kittens again, take a breath. I would not be working in this field if I didn't think there were hope. And I really do. And it's at our fingertips, and it's what we're here for. That roundup of the legislative things that are going on in Michigan was fantastic. And that's what we're going to have to head into. But here's the historian in me saying, all right, let's figure out the how and the why of going there. Why is this happening now? Why didn't this happen 20 years ago, 30 years ago? Why are we reaching this tipping point right now? There are a few answers, the first of which is Matthew Campin's answer, which is what we call toxic debt, where all this plastic that's been lying around, breaking up over many, many years, all going to microplastics, is starting to get into the body because it's small enough to do so. But here's the counterintuitive one, and actually the one that we can really intervene on, which is the climate crisis itself, which has become almost as undeniable as the plastics crisis. I say almost because there are some holdouts, but last year was the hottest year on record. Bill McKibben will point out that record, actually, if you look at what was it? I think it's the geological record. I can't remember exactly how he characterized it, but going back 125,000 years, 2024 was the hottest, which means that we are now living in a climate that's a couple degrees hotter than the one that our ancestors evolved for us to survive in. And that is significant. And people are responding to the climate disasters that are happening all around us. This is the good news. 93% of all new energy infrastructure created in 2024 was renewable. If you actually step outside the United States, most of the world is moving to renewable energy. So not so bad, unless you are a fossil fuel producer, in which case your market is shrinking in places that aren't still building coal plants and so on. So you better look for another market. If plan A was fuel, plan B is plastic, because it's another place to park all that fossil carbon that you're pulling out of the ground. And the companies are smart. They're really smart. They know how many trillions of dollars fossil fuels, fossil resources are still in the ground, and they want to be able to access them and utilize them. So that's a really big part of why so much plastic is now flooding the market. And it's not a secret at all. This is British Petroleum's expected growth in what they're going to use oil for, which is plastic, plastic, plastic. So that's their forecast to their shareholders, to the public, to everybody. But of course, this is compounding itself because plastic is a climate problem itself. Plastic is responsible for 5 to 10% of all greenhouse gas emissions, and it could exceed 20% by 2050. If it were a country, it would be the 5th largest greenhouse gas emitter in the world after Russia and ahead of Brazil. And if the plastics industry continues to produce plastic at the rate that it currently, which is 2.5% annual, or that it wants to, which is 4% annual, it will exceed the carbon budget for the world. Meaning, even if we decarbonized the entire global power grid right now and only made plastic, we would still not be able to stick to the climate goals that were laid out to keep us below 1.5 or even 2 degrees centigrade of climate change. So that's the role that plastic can play. So how are we going to solve this? Believe it or not, the big answers are at our fingertips, or they can be as long as democracy holds. In the short term, because many of you are clinicians, it's empowering to people and it's empowering to patients to be able to do something that they can feel and see and change right away. So advice for people to lower their exposure to plastic starts in the kitchen, in their food packaging, not using Teflon, and also in the kinds of implements that they use for cooking. So you can advise patients and your best friend to get away from plastics in the kitchen. You can also advise them to get away from plastics wherever they can in infant care. So bisphenol A free is not enough because they use alternative bisphenols, which are just as bad. If at all possible, moving over to glass, moving over to the old time baby toys. They're not as pretty and they're not as cute, but they're a lot less toxic, especially for children who are still mouthing everything. And things that you're in contact with all the time or for very long periods, like sheets. You're going to sleep on them. If they're made out of microfibers, you're inhaling all of the microfibers all night long that are coming off of them, and they're on your skin. The same with carpet, and the same with like pajamas or workout gear. So moving away from synthetic textiles when possible is also a good one. And then here's the taller order. PFAS filters, which basically are a sentinel filter. By the time you've filtered out PFAS, you've gotten rid of like everything else. Reverse osmosis is the gold standard. And this is flippant, right? Telling anybody, oh yeah, go and get yourself a countertop PFAS filter. It'll run you, 120 to 500 bucks. That's a capital purchase, but it's also not really solving that much of the problem. You should really get an under the sink one, but that's an even bigger capital purchase, and it's still one sink. Really what you want to do is get the whole house filtered. That way the water that's coming through the shower isn't, your pores are opening, it's hot, you're not taking in through your skin all those toxicants. Well, that's between $10,000 and $20,000. That's ridiculous. I mean, some people can afford that and some people will prioritize it, but that's not something that you can really tell people with a straight face is an honest answer. And that is because regulatory systems are really the most efficient and the most just, honest answers here. We need to turn off the tap at the production end. We need to reduce the quantity of frivolous single-use plastics. We need to ban as many of the toxicants that are unnecessary in the plastics as we can. And Europe is actually setting standards that are absolutely and eminently followable, banning phthalates, banning bisphenol A, and so on. The markets adjust, they don't die. So those are the kinds of regulatory changes that we want and that we need. And they start with things like bag bans, and they move out from there. Here's the good news. Basically, the entire public already wants this. This has been true for a long time. Every poll I've ever seen comes back between 81 and 95% of the people polled say that they want regulatory national policies It's true in the US, it's true internationally. The whole world was plugging for the plastics treaty, which was derailed, by the way, by industry, not by the populace. Populace wants this. And this is good news for us as healthcare oriented people and our credibility, because the way to push this envelope, we didn't get anywhere really with litter. People didn't really care. And we didn't really get anywhere with sea turtles. Like some people cared, but most people said, oh, that's a sea turtle problem. That's not a me problem. But plastics in health is a me problem. And people who learn about plastics in the heart, in the testes, some in the newborn, they care a lot more, to the point that 65 to 90% of people who are preoccupied with plastic or who think it's a problem are specifically thinking about their bodies and about their health. And they're reflecting the most popular studies, the most read studies, which are the brain and the heart one. Now, frankly, the scientists are most worried about the one down here, fertility and reproduction. But one way or the other, it's all the hormone system anyway. So the more people hear about it, the more worried they are. And this is my favorite statistic of all. This came out of NRDC just last year. Most people, many people, there are interesting studies on this. They feel that they shouldn't bother speaking up because nobody else is in favor. But it turns out everybody else is in favor. So, okay, a lot of people don't think that politicians are going to do anything. And politicians are concerned that if they do anything, they will lose their votership. Absolutely not the case. It turns out that most people look more favorably or would look more favorably on lawmakers who support measures to reduce plastics. So using this information and this understanding, we may really be able to move the needle with lawmakers themselves to try to demonstrate, look, the public wants this. Listen to the public. You can join this fight, this particular group very much so. My organization, PSNAP, is networking people who want to plug in. I try to meet everybody where they are. So if there's something that's really sparking your concern, microplastics, healthcare plastics, whatever it is, I organize working groups and put people in touch with others who are specifically worried about those things and want to take action and are thinking about ways to do so together. I also like to send out a lot of panels to professional conferences, because every professional conference I've gone to that has a room about plastics is standing room only. So we want to use our voices even more to get this out even more in medicine, because physicians, nurses, healthcare personnel in general are disproportionately heard in this domain. So thank you for your attention. I probably ran over time. Oh my God, I didn't. That's crazy. I didn't even run over time. It's a plastics miracle. Anyway, there's plenty.